In today's video, we are going to program the simplest neural network you can imagine. We are going to use the library PyTorch. In this video, we are going to use one single layer with one single neuron. And the only thing it's going to predict is whether someone is over 21 or not. So the input stream is from 0 to 100, and the only thing the model predicts is if it's over 21 or not. So the first thing we are going to do is generate x and y. We will do that in this function, and I will break that function down. So we will create a NumPy array containing 100 items ranging from 0 to 99. The target will be either 1 or 0, depending on the element being over or equal to 21 or below 21. Then we're going to convert everything to torch tensor, because the tensor is what we need to have as input and output for the model. Let's print input and print target. So the input is, as said, a tensor ranging from 0 to 99, containing all the numbers or ages, and the output will be 0 or 1. So that's for input and target. If you're interested in the shape, it's 100 for each, but we need the input to be 100, 1. So therefore, we will use unsqueeze and defining the axis to be 1 and convert everything to float. Let's have a look what we've got now. The batch size is 101 and the target is 100. Let's have a look what it will actually look like. And as you can see, the input is a list or an array of arrays containing a single value. So we have 100 single values, and that's what this is about, 100 single values. And the target is just 100 elements. So that's for this, but don't forget to scale everything. We will divide everything by 100. So we do not get a value ranging from 0 to 99, but rather values ranging from 0 to 1, or in our case, just 2.99. So we can get rid of that. So that's for our data. Now we get x and y, and now we focus on the model. The model is very simple. The model contains a linear layer containing only one neuron, and the output will, or the activation will be sigmoid. So our output will only be in the range of 0 to 1. We will train everything for 100,000 epochs, and the criterion will be binary cross entropy loss. So we just have one class, either being over 21 or not. So we will use binary cross entropy loss. The optimizer will be Adam, and we will give it all the model's parameters, and the learning rate is pretty low, so we can get to good loss. This is only for visualizing the training loop as it progresses to have progress bar. So we will iterate over every epoch, and this is our loop. The next thing we are going to do is we want to list the losses and accuracies over time. So we create 2 empty lists, and now we are going to iterate over the loop. The first thing is we have to initialize the optimizer and set the gradient to 0. Otherwise, it would iterate over each gradient and add all the gradients together. That's not what we want. The next thing is the model gets the actual input, and it will actually output something. Then we need to calculate the loss, and the loss is calling the criterion. The criterion is the binary cross entropy loss. Here we need to get the output flattened, and I will show you what the output shape is going to look like. Output shape. And I'm also going to print Y shape, and we will exit so we can have a look at the shape. And the shape is 101 to 100. If we flatten everything, it's both 100. So for our loss function, we will flatten the output. So we have two 100 long tensors. Then we will calculate the gradient by calling loss backward and the optimizer step to actually affect the model and to actually make the model better. After that, we will calculate the accuracy by giving it the output and the y. The next thing is calculating the accuracy by giving it the actual output and the target, and it will calculate a percentage from 0 to 1 or 0% to 100%. This is for us, for the progress bar, keeping the actual loss at each epoch and to have a better visualization of everything here. Those two lines just append to our list, to our storage, that we can focus on the actual training and have a track record of the losses and accuracy. This part here, if we want to have also a visual representation while training, we can use this line here, and I will show you how this will affect the visualization process. If we run the program now, we will get 3 plots. The first plot is the training loss. You see, as you can see here, it will decrease over time. The second plot is the actual accuracy, and it will increase over time, hopefully, if we did not do anything wrong. And here, a very cool plot is the red thing is the actual target, what we want to achieve. So we want to get 0 for every value that is below 21 and 1 for every value that is 21 or above. So this is the target we want to get, and the blue line is the actual model output. And as you can see, over time it will get better and better, and it will adjust to the red line. If we update every 100th step instead of every 20th step, it will actually train faster because the updating process takes a lot of computational effort. So if we update every 100th time, you can see here it will update less frequently and therefore will update faster. And we can even update fewer and fewer times. If we want to speed up training, we get rid of the visualization during training at all and only visualize at the end. So here, let's train for 100,000 epochs to make that point clear and visualize at the end. And as you can see, the blue line almost fits to the red line. So the model is very, very sure or certain having a certain value. And as you can see, the loss over time decreased a lot, and the accuracy is still at 100. I hope you've liked this video. If you did, please give me a thumbs up and subscribe to the channel.